Welcome back to Captain Castle's laboratory for part 3 of the Octo swing, where we're going to, it's going to be a shorter one, I hope. I'm going to show you how this 5-volt cell phone charger from a car will power everything. And I already put in the circuit just to save some time because I didn't really modify it too much, but I did a little bit, and I'm going to go over all that with you and then show you that it works. Because I don't have the top on it, I just stuck a temporary motor in here to show you that it still reverses. So, it does what it's supposed to do. And you'll still see some of the lights. I'll try and bring it in frame. I'm going to zoom in, but we're going to go over it, and then I'll show you how it works. I was going to reassemble it, but before I do that, I want to test out that soundboard that I showed you in part 2. So, here we go. Went ahead and took that 5-volt USB cable, cut it down because it was really long, if you remember, or you may not have seen the whole thing. It was about 3 feet, way too long. And these you can get from old cell phone charger. You break the end off that goes in your phone. There you go. You got a new one. There's 4 wires on the inside, and I will show you that. So here's the cable. I'm going to trim off the insulation. And we have, on this one, it's green, white, red, and silver. The silver one is ground, and it's also used as a shield. So that would be your negative. So your red is hot, your silver or bare strands is the negative, and then the green and white are your data wires for transferring data. But for charging or power, we only use these two, and then we cut those two off. So this was the other end I was using. As you can see where I soldered the wires together. And now it looks horrible because I've soldered it like 18 times to do different tests. Now this piece of wire is just wire scrap, or throw it in a wire recycling bin. So if you have any USB-A to any C, B, micro, whatever, you can do this. Alright, so you don't need anything special. Oh heck, go to the dollar store and buy a cheap one. I did extend. These are the red and black wires that go to the rotor. I extended them so that way if this needs to be opened again, they're not pulled taut. They're a little bit looser, so you can fold the top over and still have it plugged in. The reason they're not plugged in is there's no motor attached, and the motor is right there. So kind of pointless to have the motor attached to it. Just it wouldn't do anything. You wouldn't have no proof that it's working. All right. So I'm gonna rotate this a hair. Here is the USB 12-volt to 5-volt. If you didn't see part 2, what I'm referring to is it's one of these. This is a 3-head. This one's a 2-head. The reason I'm not using this one is this one that's green is a fast charger. It puts out 9 volts. A lot of fast chargers put out 9 volts and standard chargers put out 5. If I run 9 volts to the motors, they're going to burn up. They're only rated to run between 3 and 6. 9's a little too high. Also, this is much taller. Even if I lay it sideways, it's fine. But I only need 2 ports. One to power the motors, and one to power the speaker. So we're good. This is a 2-port. You can see 2 ports. And this is a power tester. So you can plug your USB in here and it tells you the amperage draw. So I am going to put this in here so we can see this, so you can see this. So when we test it with live power, you can see how this thing works. That's how it works. I'll turn off some of the lights so there's no glare, but I'm going to pull it back out so I can show you the little bit of a modification I did to this board. So this, if you saw it in the last one, had a little nub sticking out on the back here. I told you I'll probably just desolder it so I can solder the wires directly to the board. I'm going to zoom in. Probably be easier. Here we go. Whee! Wrong board. Right, board? All right. So that little nub is what presses against this on the end. I know it's not in focus, but you get an idea. So I desoldered it, and I soldered a hot wire to one side and the capacitor to the other. I mentioned it, I was going to put a bigger capacitor in. That little spot right there is for this little guy right here. Focus. There you go. If you can see, it's upside down. It's 5 volt, 25 volt, 22 microfarad capacitor. It's itty bitty. This guy is 35 volts. Again, voltage isn't as big of a deal. You always want to make sure your voltage is higher than the voltage coming in. But it's 1,000 microfarads, and you can see it's much, much bigger, like superior. Anyhow, what that's going to do is help smooth the noise on this circuit board, so it doesn't backfeed all these wires to this circuit board, which is our breadboard with the 2 chips, or this guy right here, which actually has a logic chip. We don't want any backfeeding. This will smooth it out better, being 1,000 microfarads than the 22, and it'll last longer because you can tell by the size, there's going to be less load on it. So, how you do it is you connect the hot to the incoming power and the negative, because this is polarized, to the negative. Now what I did on this one is I soldered it to the bottom of the board on the negative pin, as you can see there, and then there's the hot wire and the positive for the capacitor, and there's a negative symbol in case you haven't seen one before. Now the ground I just have pushed into the pin. Reason being is I'm actually going to use a spade connector on it and push it on. I don't want to desolder it. And soldering to this thing has to get so hot that it can damage the chip since it's so close to the chip. So I'm just going to get a spade connector and crimp it on. It's only on temporarily for testing. And the wires go over and they're soldered to the hot, and the hot coming off the switch and the negative coming off the incoming power port. Just like these wires here and this wire here and that wire there. So all the reds, except over here where I used, well, that is red. It kind of looks, well, at least on my monitor it looks purple. But red, 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 hot off the switch, black, 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 negative off the incoming power. Like that. So here's the incoming power. Power, hot, goes to the switch, and the switch bridges it over here. Yeah, there's a lot of wire soldered on the negative, so there's a big ball. And I will coat that to prevent it from arcing against the hot. It looks close in the camera. It's not that close, to be truthful. But we don't want any future issues. That's what we're trying to avoid. So, now I didn't grab a 12 volt AC adapter, so I just have my meter or my machine connected to bridge across, so I don't have to keep pressing the button. This resistor, again, if you didn't watch the previous ones, goes to the lights that light up the actual octopus on the top of the unit. So let's get this back over. And we're going to plug this in. I am going to hot glue this down, just like I hot glued that down. This one's screwed, but that's actually hot glued. Make sure that when I moved it, I didn't make anything touch, because things will sizzle, pop, and it won't be good. I'm going to move this over here. Actually, right here, you might be able to see the screen pretty good. There's no glare. If there is, I'll turn off the lights. Yeah, you can see it decently. I'm going to turn off one of the lights, see if that helps a little bit. So this is putting kind of a load on it. It's dropping below the threshold voltage of 4. And that's because of this motor here. This motor is a higher powered motor than what the unit comes with. And then the motor on the top is spinning. It's just constantly turning as soon as you give it power. So I'm going to remove the reversing motor. And if for some reason this isn't going to work, I'll swap it out for a bigger one. This guy is only rated for about a 0.5 amp, and the 2 motors that are in this unit don't draw anywhere near that amount. So, but this guy does, especially with this eccentric load. So, as you can tell, this is much fatter than a standard Lemax motor. This is normally the motor that they come with. Focus. There you go. And you can see, much bigger. It's about the same diameter, but it's taller. So this motor draws more power than this motor. This motor is what's in this unit. So I'll take them out and give it power again. You can see 5 volts, 5.05, 5.06. It's drawing minimal amperage. So you can see that it's pulling through here. You get your milliamps, your full amps, your total duration. And you can hear that clicking. And let's see if I can turn this. There you go. So that's turning. And then you can see the lights between my hand. The purple one's going off and on, and the green one below is strobing. Yes, I know that top motor is loud. I've changed the motor because and that's a new motor, and it's just as loud as the old one. I think it's the way the gearbox is on this. No idea why, but it is what it is. When the sound goes in, it won't be as bad. Also, when the top's on, it's not near as loud as it sounds on camera. So, got to take all that into consideration. Now, referring to this bigger capacitor, if you use the small one, it means that you'll put more noise into the circuit. Now, the circuit noise is very important when it comes to IC chips, like those, especially that one there. This is a little more, it'll handle it better being a timing chip, but that guy right there isn't going to like it so much. So it is important to have a isolation capacitor or a smoothing capacitor. The system already had it. I just removed it and went bigger. It's always recommended to go bigger if you can. And that way you get less noise actually in your actual circuitry. What the noise in the circuitry does is it causes problems with the like this being a switcher, switches left, right, or on, off, or forward, backwards, or reverses polarity, H-bridge. It can cause it to not cycle at every 5-second interval that it's set for. And that would cause a screw up in the timing, and eventually the chip would be able to handle it, and it would fry. And, well, that would be bad. On this, eventually the noise could affect the chip and these capacitors, because they're much smaller, and cause them to fail. Generally, it won't hurt the timing chips as much. Timing chips are pretty resilient unless you reverse polarity or overpower them, and then you'll have a problem. They'll start to sizzle, smoke, and make some popping sounds. Kind of interesting. So don't do that. As far as the lights go, the noise in the circuit can cause the lights to flicker. So the pulsating, it wouldn't pulsate smoothly, meaning the purples. The green lights that flash, you probably wouldn't notice because they just flash on, off, on, off, on, off. So there's not much. But the top lights, the ones that go in the octopus head, those are flickers, and they might flicker erratically. Instead of a flame-like flicker or smooth flicker, you might get more of a violent flicker, and eventually they might burn out. So I'm talking about the lights that are up here inside this cap. Once those are put on, then I'll coat that so it doesn't affect anything. And that's because the black wire has to be soldered over here as well, and then the red wire gets soldered here. So as soon as you give it power, it sends power directly up to the lights on the top, and then of course the power breaks to over here, and over here. So like I said, and this is the easiest way to step down on something that's 12 volts. So if you have a 12 volt supply and you need a 5 volt output, approximately, because some of these aren't 5 volts, like I said, you can get a rapid one that's 9. You can use an old car charger. I always try to overpower them. I mentioned that before, meaning if I'm pulling a ½ amp worth of stuff, I want to run a 1 amp or stronger charger. I'm not going to run a ½ amp like this one on it. But since this is only running 2 motors, and possibly recharging the battery on the speaker system, if it doesn't work, I will change it to a higher amperage one. The 2 motors together don't draw enough for this to even flinch. The factory motors, not that bigger one I use for testing. Just so I had something to hold on to and show you. Because it has a longer shaft, I can put the tape on it so you can see it reversing. Just because you hear it click doesn't mean it's actually doing its job. It is a circuit. I'm trying to zoom back out a little here. Always do that. Never fails. Always go the wrong direction. But that's one of the reasons I haven't hot glued this in yet, is because I want to hook the upper motor for this on, have everything working, and if this works perfectly and I'm not losing power or resetting like I was resetting that digital display, then I'll hot glue it in, call it good. When I tested it outside of this unit, when I did it on the bench where I had power to 2 motors, worked perfectly, never reset, never changed, we're good to go. But now it's competing with other components, so if it can't handle it, I will change it. And then the next step would be seeing if I can get this to work. And then if I can, I'm going to have to make some notches in the back for the power. Possibly the power I might just hook to the switch, but for the volume and the on-off button. That way, just like your normal one, you can turn it on and off. Or I can just keep the on-off button. The on-off button's a momentary. I thought about that. You can't just short it together. It screws up the system because it's set for a non-latching switch. So it does still need that on-off button. Click on, click off, and then your volume switch. And this comes with a short cable, and because that's a 2-port, I should be able to run it. I still got plenty of room to put stuff. I mean, I can technically unscrew this board and move it. I can glue it here. I can turn it. I can push this farther over. You just want to make sure that these outer holes are not covered by anything, because that's what those screw into, and you don't want to screw it up. You also don't want the screws to go through the wires. As you see, the wires covering here, but once it's put in, I can hot glue the wire right there. It won't interfere. This one is a short, like I said, much shorter. We're less than 20 minutes at the moment on how to do this. The only modifications I said that I did to this is I removed the nub and soldered the wires directly to it, removed the capacitor and soldered the wires directly to the board. The reason I didn't use the factory 2 capacitor holes is, well, that's a much bigger capacitor, and I don't want the leads touching. So with this little guy, I just soldered it across. And all I did was use a pair of needle nose to bend the legs so that the legs are bent in a angled pattern, so it's not all weird looking. Also helps give it a little rigidity and keeps it away from anything important like the chip. I don't want the wire, the legs to bend and touch any of the chip legs, because that would cause a short or an arc. So, but yeah, that's pretty much it for the third set on how to take 12 volts in, and instead of building a circuit, dropping it down to 5 volts. You can go on, you may not like it, Temu, because they have it cheaper than Amazon. They have a voltage regulating circuit board, which I was going to possibly use. Where did I put it? I love when I have it out and then I move it and then I don't know where I put it. But, here it is. Nope, that's not it. That's a bridge rectifier, or H-bridge. Well, what it does is you give it power, and no matter what, the output is... Oh, there it is. No, that's not it either. I literally had it before I started filming. But it's a power regulator. You can put anywhere from 1 volt all the way through 24 volts into it, and it puts out a consistent 5 volts. So it can multiply the voltage if the voltage is under, and it can decrease the voltage if the voltage is over. It was like $4 on Temu, and it works. I've tested it a couple of times on a few different circuits, and I literally pulled it out last night. And then I moved it because I needed room to put this up to do it again. And oh, old age sucks. Wait. I think this might be it. But there is other options if you don't want to use an old cell phone charger, is what I'm trying to get to. I just want to try and show you it. Come out. This is a different style one, but you can see how big it is. That's why I went with that. I have another one. I bought a couple that they had in different sizes, but this isn't the one I was looking for. The other one is the one I was testing. That's why I had to use to peel this package open. Because some people don't like Temu. I've bought a handful of stuff from them, haven't had any issues, and all the stuff I've got from them works. Here it is. I found it. I moved it underneath that. So voltage in, voltage out, and there is your regulator. And there's your trim control, so you can get the exact voltage you want. And because sometimes it might be 4 volts or 6 volts, you can trim it back and forth. But this can go up to 24 volts in, and it puts out a consistent voltage. And it's set for 5 volts plus or minus about 50%, because you can actually go as low as 2 volts or 2.5 volts, all the way to like 7.5 volts. But this would work too. The only thing I don't know is how much amperage it can handle. Like this is rated for 0.5 amps. And this one that I was showing you, this rapid charger, this guy is rated for 3 amps. The 9 volt is 2.4 and the 5 volt is 2, but it's a 3 amp total. So if you plug everything in here, it won't exceed a clip. I don't know what the amperage rating is on this circuit board, but they do make circuit boards that you can buy too. But see how tall that is? That's the heat sink, because this thing gets hot. It's too tall. That's why, again, I went with one of those. So plenty of options out there. Sometimes you just have to look and see what you have available that you can use. So that's why we're the Random Junk Channel. I literally have tons of car chargers that people don't want, or they don't put out enough power for their newer devices, or it's for a dashboard light for a security or police car, and it's bad, but the inverter inside, which looks just like this, except instead of having a USB, it's got 2 wires that come out to get connected to the light, as an example. They still work. They still are a good step down. 12 volts to 5 volts, give or take a little bit, because there's always a tolerance. So, but anyhow, no more rambling, no more basic, it's just basic stuff. You don't have to go buy anything expensive. That's the greatest part about it. So, any questions, comments, put them below. Stay tuned for part 4 sometime in the near future when I work on the soundboard, because I'd really like to get through all the projects, because we are hopefully within less than a month about to start moving this room into a much larger room. and I won't be able to film for a couple of weeks during the process. So we're hoping to do it sometime during the month of September, and right now it's the 10th of August. So time is running out. Well, like I said, any comments, questions, concerns, leave them below. Try to respond to them as best as I can. Other than that, that is how to use a car charger to step down your 12 volt incoming power. If you do something like this, make sure you are fully aware that if you plug in the wrong voltage, such as a 4.5 volt Lemax plug, it's not going to work right. And you could actually damage the stuff that's in here. So just be mindful. Make sure you mark it. You can write on the bottom a Sharpie or put a piece of tape on the bottom. It's a 12 volt piece after you've modified it. I don't know how Lemax does it, but most of their circuits are 4.5 volts to do all this, and I cannot find any replications of the 4.5 volt circuits. It's not a standard voltage for doing this stuff. So until the next one, thanks for watching.